Hello friends, welcome back to my YouTube channel. This is tutorial number 2nd, and in this tutorial I am going to show you how can you extract simulated data from your simulated model. So let's get started. So first you need to know we have a lot of data we got from our simulation. Like suppose this is temperature. You see it keeps changing. Similarly we have plastic strain rate. If you go to S, this is stress, this is temperature. So we have a lot of data, so now we can extract this to our Excel file or origin file, and then we can process the data, and that data you can publish. So that is how it works. So I'll show you how can you do that. So like suppose we want force data, we go to here XY data. From here select field output, ODB field output, continue. From here make sure to select unique nodal, and we want force data, so we go to reaction force. You see here reaction force. From here this is X, Y and Z direction force. If you want magnitude, you can also select the magnitude. Now from here we go to node labels, node set. From node set we'll select reference point 1, and then we'll plot. It will take a couple of seconds. You see now we got simulated curve. This is force, X direction, Y direction and Z direction. So now we have our force curve, but you cannot directly use this for your article or your paper to publish. It need to be processed. So for that you have to import this file. You cannot do processing over here. You need to process either in Excel file or origin or something else. So for that I will show you how can you export this their data to your Excel file. First you go to tool, this one, plugins. Plugins, go to tool and Excel. After that you select them, X axis, Y axis and Z axis file. Press apply. It will take a couple of seconds. So now our Excel file is open over here. These are time period and these are our force at different time. What was the force? Okay, these two are time, so I will delete them. This one time is okay. So now this is X direction, Y direction and Z direction, and this is our time. So I will plot it and I will show you this one. So this is our force curve. However, you cannot use still this data for your paper, because you see there are a lot of up and down data. It have to be processed well. So you can even do processing over here. How to do is like you have to find similar type of data. If the data is repeating 2 or 3 times, you cancel them. Find point near to each other and then try to plot it. You see there are a lot of data, so it will take a lot of time to do like that. I'll show you. I have processed my data in Origin and how does it looks after processing. You see, this is force curve. So after processing it looks like this, and this data you can publish or you can use that for your article. So I will show you. If you are interested to learn how to do processing, I will show you that in another video. Okay, now I will show you how you can extract temperature data from your simulated model. We go here, let's keep it running. We go to tool, display group, and then go to create. From here, make sure to click part instance, and this is our tool. We call it ball mill. From here we remove it. See, now our tool is removed from there. Let's zoom it so that we can have a proper view. So these are chips formation during manufacturing. These are the flying chips, and you see the change in color in them. It is called heat flux. It has just appeared for a couple of seconds when the cutting tool and the workpiece get in contact to each other and removal of material take place. At the time, the highest temperature is generated in the cutting zone. This is called heat flux. In another way, it is also known as thermal coupling. There are a lot of research going on these thermal couplings, because it is very, very important in the term of manufacturing of any part or component. Imagine your workpiece have a low specific temperature, but when you are machining it during manufacturing, if your tool is producing a high temperature, it can easily damage the surface of your workpiece. So no one wants irregular surface finish during manufacturing. So it have to be studied properly, and you have to find a proper tool how to reduce the temperature. So that is why this is very, very important in the term of manufacturing science or material science. I'll show you now how to get this data. Let's first turn it so that we can have a proper view. It is running, so it is a little slow. Now we go to XY data. From here OBS is okay, continue. From here make sure to click on temperature, then go to element nodes. From here node label, node set, go to pick from viewpoint. Okay, select node in viewpoint, edit section. From here you can take a random point over here during manufacturing, and then we have to get average of that. I'll show you how to do that. Like suppose I will stop here and I will try to take some points from this surface. 1, let's take 2, show you this one. Okay, now press plot. Oh, okay. Again we have to edit section, go to some point, now plot. See, now we have a temperature curve. You can select like many points on your surface, like you add section again, like edit, select them. Just I did like that, but it will take time, so I will just show you few points over here. So now you see we have a curve. Still this curve we cannot put directly in our paper, it have to be processed. And same thing, you have to import this file because you cannot do processing over here. So to import that, go to plugins, go to tool, go to Excel. Now from here you can select, these are our 3 points, and we'll say okay. Once you have this data in your Excel, you can easily modify them or process them to make a nice curve which will be more meaningful. Here a lot of people, they cannot understand what is going on over here, but when you process the data, it will give you proper meaning. How does it works? I will show you one. If you are a young researcher, it is really very important to know how to process your data. Now go to, these are our Excel file, these are time period, you must know these are time period, and these are your data. You see there are so many 000, so there should be processing. You cannot keep, because these a lot of 0, they are useless to our data. We don't want a lot of 0 in our chart. You have to remove them. Delete. Now we'll plot them. You see, so after processing, you have to process them. There are a lot of data, so similar type of data you can remove them. You see there are a lot of data. So now I'll show you after processing how does it looks. I have processed our data in origin. I took 2 points. So after that, you see at point 1 it shows it has the maximum temperature of around 100, maybe 18 highest, and then it start to decrease. Similarly at another point it reached up to 45, 44, and then it started to decrease like that temperature. And this was for very short period. You see the time period was 0.004 second. So the time period was very small, so heat flux is generated for very small time. You have to make sure to catch that peak time during manufacturing, because it can really hamper your material surface during manufacturing. So this much for today. If you want to know more about data processing as well as simulation, CNC coding, a lot of things, even MATLAB and Python, please don't forget to like and subscribe to my channel. I hope you all can be happy every day. Bye bye.